Hello, everybody. Good afternoon. Good morning. Thank you guys for joining us for our second ever Tech Spark. My name is Andrew, and I'm part of Meanwhile USA's direct sales team. I'm also joined by Brian Liu, our product expert and engineering manager. So today we're going to be talking about our 3+N product line and going over some case sharing examples as well. At any point, if you guys have any questions, please feel free to type them in the chat below, and our product manager, Kai, will be happy to assist you guys. So Brian, do you mind going over today's agenda?
Yeah, sure. My name is Brian. I am the application engineer at Meanwhile USA. So the agenda today is we're gonna briefly reintroduce the 3+N product categories, and then we will share 5 or 6 case sharing of each category, so that you gonna help you guys capture the market or target some customer in the future.
Okay, yeah, perfect. So let's go ahead and start off by going over what our 3+N product line consists of. So as most of you guys already know, we specialize in power supplies with our enclosed open frame LED and Israel power supplies being our bread and butter. And about a year ago, we launched this initiative to promote our 3+N products, which are essentially a level above those standard power supplies you guys are all accustomed to. And our 3+N products, they come with unique features, including built-in communication protocols, such as CAN bus or PM bus, water cooling, multiple outputs, and complex functions that typically require support from our engineering team. Simply put, 3+N, that's our line of complex products that are often assembled into turnkey solutions, which we're going to dive into in just a moment during the case sharing examples. So Brian, if you don't mind, could you tell everybody here a bit about each of the different 3+N product types they see on the screen here?
Yeah, sure. So we have like 10,000 different products, and those a lot of them are easy to use, like simple AC in, DC out, 120 in, 12 volt, 24 volt out, and a lot of customers are familiar with them. And so we introduced the 3+N, which is another level. Okay, it can do very high output power. It has intelligent control and also have high output voltage. And so that a lot of them, they are used to target like some niche and emerging market, like energy storage, RF generator, centralized power. I mean, the cost of the units is also high as well, so it's going to make it easy for you guys to meet the sale target. And so what is 3? 3 means the modular power, the rack power, and the system power. So modular power is, we have 650 watt to 1K, and a single unit and with multiple output. The advantage of it is like it's space saving, save your installation time, you reduce EMI risk, and also lower the leak current of the entire system. And the rack, we have the 3 kV, 3K watt to up to 12K watt. They're 1U high, and usually used in the 19-inch rack, and also popular in data and telecommunication field. The system power, the last one is it's basically multiple unit. Okay, either rack or high power, putting into a 19-inch rack cavities to support applications like high power. If customer need like 100 kilowatt, 120 or 350 kilowatt high voltage, low voltage, we can do them all. It's like a turnkey solution. And in combined that is an N. Okay, N is like an infinite combination. It has the intelligent control CMU2 that you use to along with our power supply to control and monitor. Or it had the DALI. Okay, we have DALI that control the LED lighting. So for example, a smart controller CMU2 can be installed inside a 19-inch rack to monitor and control 50 rack power. Okay, the health of the power supply. So in summary, 3+N product line is pretty wide. Okay, it's not like an open frame, enclosed or thin rail. It's high power and have a lot of unique function that can help customer to solve the problem, application problem.
Yeah, great. Thank you for that breakdown, Brian. And I think hopefully that should help you guys understand our 3+N product line a little bit better. But I think the best way to learn more about it is really to jump into the application. So let's go ahead and get into our first case sharing example. So our first example is going to be a system power solution. which Brian just described. So here we designed a system power solution for a customer. They're a drone company. They shoot these huge drones into the air to deliver goods such as vaccines, medicine, groceries, things like that. And so basically they needed high power and voltage to drive that motor that would initially launch the drones into the air with enough velocity. This is because once the drone is fully in the air and moving fast enough, it would run on battery until it finally reaches its destination to deliver the products. So in this case, Brian, do you think you could tell us a bit more about the products that are involved in this system power solutions and maybe some of their key features?
Yeah, sure. So the customer initially they need like a 70 kilowatt and 305 volt to drive power their motor, and they also looking into one single package, and the controller they also want something user friendly so that they can control and monitor the voltage. Sometimes they want to make it lower or higher. They can easily change the voltage. So our solution is that we don't have one single power supply that is 70 kilowatts. So we were proposing the 15U rack. Okay, it's 15U rack, 19 rack, and we're putting 32 NCP 3200, 380 inside the rack, and so that gonna give up 70 kilowatt and 305 VDC, okay, to support the application. And on top of that, we also put the CMU2 controller so that the customer can use the CMU2 to control the entire bus line. Okay, and moreover, our solution team also designed the terminal block play, and also sourcing the breaker so that the customer can turn on and off the entire system and then terminate the power into the terminal block. We also design the bus bar, okay, so that we can parallel all the unit. So it's like the entire system is ready to use when the customer get them. It's easy and ready to use.
Yeah, and speaking of ready to use, I want to kind of explain what we did for these guys. Just summarize. We helped put together a turnkey power solutions for this drone company. And for those who don't know what turnkey means, basically it just means a complete and ready to use application or solution. And so basically for this customer, we help meet their high voltage and power needs, all while providing a very easy to use control interface.
Yeah, I mean, this type of turnkey solution, the cost is really high. You don't have to sell like 100 or 200 per year. 10 is gonna, if you can do 10 per year, it's gonna help you, push your sell target.
Right. Okay, yeah, and next up we have another example of a system power solution. Here we designed this solution to provide power to the lights for a horticulture company. So here, instead of supplying each individual light with its own power supply or LED driver, which would not only be heavy, but also very expensive, the customer decided it would make a lot more sense to use a centralized source of power and then distribute that power throughout all the lights in their wiring system. So for this case, Brian, how do we meet this customer's power requirements, and what do you think made this system power solution so special?
Yeah, I mean, another system power solution is it's for a centralized power application where the customer need a system, a cabinet power that they're gonna put inside an electrical room, and then they're gonna bring the power into the go room. So the requirement was that they were looking for a multiple system, and each system is 120 kilowatt, very high, 120 kilowatt, and they want to have like 12 individual output, and each output is 10 kilowatt to power 10 LED. So and the system is very high power, so the input voltage had to be 480 volt. It cannot do 208, and so we were proposing the SHP 10K at the time, that one will have 10K power, and putting 2x6 into the 15U rack power, so that total unit is 12, and each unit can power 10 array. Okay, and the SHP 10K also have constant current limiting feature. Okay, that can be used to drive the LED directly. And what nice about the solution is that it also help the customer to easily dim or control the light fixture. Usually lighting application doesn't matter, it's luminaire, grow light, they all need to be able to dim. Okay, so the customer also use the PC function to dim the light when they don't need, and also use the RC function to turn it on and off. So in summary, it's another system where one cabinet fit 12 SP10K and drive the LED directly.
Okay, yeah, and I guess just to recap, here we helped again this horticulture company design very high input, 480 volts AC input, and also high output voltage. We made a system power solution for them to distribute that 120 kilowatts throughout their entire LED lighting system. And this solution, it turned out to be extremely efficient, and it even allowed for remote on and off control as well as programmable dimming.
Yeah, I mean, Andrew, the SSP10K did the job. It's meet all the requirement to power the LED, including its function. Let's move on to the next project.
Yeah. Okay. Yeah, so now that we've taken a look at a couple of system power solutions, hopefully you guys are a little bit more familiar with those. Let's go ahead and take a look at one of our previous rack power projects. So in this case, we had a customer, they were designing a radio frequency amplifier that's used for semiconductor fabrication. So in this case, the customer, they needed a power solution that would help keep their output voltage stable even through sudden drops in AC voltage, which is for those who know the SEMI F47 standard, very common in these semiconductor fabrication companies. So they also wanted hot swappability, meaning that when one of the individual power supplies inside the rack goes down, they can easily swap it out with they're working with. So Brian, do you think you could tell us more about the power supplies that were involved in this solution, and then some of their features as well?
Yes, sure. So application is semiconductor fabrication. Is the power supply is used to power the RF plasma generator to do the etching process during the wafer fabrication. So it's not really complicated. The customer only needs like 5 kilowatt to turn to power 6 amplifiers, and then so each amplifier is like 1K watt. But what they need more important is that redundancy and parallel functions, so that if one unit is malfunction, the system doesn't go down. So we suggest the NCP 3200, 3 unit in one rack, which the customer can also use three phase power to power all 3. And if one unit is malfunction, the other 2 like 6,000 watts still can cover the required 5,000 watt. And beside that, other requirement is that the CAN bus, the CAN bus function of the NCP help the customer to monitor the voltage and output voltage and output current and input to make sure that they know when the unit is when the fouls occur. Okay.
I see. Speaking of CAN bus, does the NCP 3200, does it come with a built-in CAN bus?
Yes, it does. I mean, unlike our previous product, some of them are optional or by request, but the NCP we did it as a standard model, so it's with CAN bus.
Oh, okay, nice. Yeah, and just to recap this case sharing example, with this customer, we helped put together a very convenient, hot swappable rack power solution, that can be monitored and controlled through CAN bus. And because of the NCP's redundancy features, even if one unit inside the rack malfunctions, the fabrication process will continue without any issue. Yeah, so let's take a look at another rack power solution we helped with. So for this example, we had a customer who was building an electric generator that would take an AC power to charge up, convert it to DC power through the power supplies inside, and then convert it back to AC power. So their goal with this generator was to provide a stable source of on-the-go electricity that can be used to power, various home appliances like a fridge or a dishwasher, in case of blackout, or rescue an electric vehicle, during emergency situations. So, hey Brian, for this case, why was a rack power solution a good fit for this customer, and what were some of the cool features that were involved?
Yeah. So this application is an emerging market because EV is getting more popular, high demand now. I mean, when your EV die, it's basically the battery gone. This generator is basically gonna on the go. It's gonna go to can be used to charge your car. So basically, what it does is it had a built-in battery, it had a built-in charger, and then a built-in inverter. Okay, so the battery is basically used to power the inverter to charge your car. And the rack power here is used to charge the internal battery when it's not in use, to make sure the battery is always full. And why the customer chose the rack is that the orange MOSFET function. Okay, when it's not charging, the rack power has orange MOSFET to prevent the battery voltage feeding back to the output. Okay, and also another feature is that the rack power has the control PC and PV function to control the voltage and current that allow the customer to control the charging rate of the battery. Okay, and so the battery inside is like 400 mAh, so it would take about 3 hours to fully charge the battery bank.
Oh, wow, okay, yeah, very neat application. So again, this is basically a jumbo portable battery pack that, Meanwell was able to help power. So yeah, thank you for breaking that down, Brian. Let's go ahead and check out the next project we worked on. So now that we've looked at a couple system and rack power solutions containing multiple power supply units, what about a single unit high power solution? So here in this example, let's take a look at a customer who designed these big containers that store a lot of these battery cells used for energy storage, another one of our emerging markets. So here they needed a high input, high output voltage source of power to power the compressor attached to the container to cool down and regulate the temperature within the container, and also to, of course, prevent the batteries inside from overheating. So, Brian, for this application, is there a reason why we chose the SHP-10K?
Yeah, the main reason is that the SHP-10K can do 480 volt DC delta, and also have high DC voltage to power the compressor. I mean, energy storage, is another emerging application because it usually installed under a power substation. Okay, so those substation 480 volt delta is very common, and so the application is due to power the compressor to cool down the battery internal of the container of the energy storage. And lithium-ion battery, they are very picky, meaning they are very sensitive to temperature. The best performance for it is like 0 to 40 degrees C ambient temperature. Outside of the range or beyond the range, you have to lower the charging rate or lower the discharging current, or if not, it's gonna shut down itself. So in order to maintain the battery temperature or regulate the battery temperature, the customer they're gonna design their own cooling system. So they use the SHP-10K to power their compressor. Okay, and directly. So when the compressor is on, it's basically generating heat or cooling down the battery. And so the remote on-off control function was used to basically turn on and off the compressor. So that's why that's how the SHP-10K help the customer in this case can do 480 volt delta, and also has high voltage to power the compressor.
Okay, yeah, gotcha. And pretty straightforward. Again, like Brian mentioned, power that compressor and cool down the batteries inside the containers. The customer, they needed a very powerful single unit source of power that could take in high input voltage and also put out high output voltage, all while having that remote on and off control capability, making the SHP-10K very good fit.
Yeah, let's go to the next application, which is my favorite one. It's pretty interesting.
All right, let's check out Brian's favorite application here. So here's another 3+N example, this time with the inverter solution that we discussed at the beginning. So here the customer was building a vitro diagnostic analyzer, and they needed something to power the motor inside. So they also needed a way to minimize that sudden spike in voltage from the motor slowing down, which would cause the power supply inside to go into over voltage protection mode, which is not good. It would lead to their entire application shutting down. So if any of you guys listening, you guys own an electric car, you probably heard of regenerative braking, which is essentially what the BIC 2200 provides for the motors. So usually for a regular power supply, you would have to connect a regenerative clamp to the power supply and the motor in order to replicate that effect. So Brian, if you don't mind, maybe we can go into a bit more detail and describe the BIC 2200 and also that regenerative effect.
Yeah. So we all know the BIC 2200 is very popular in the battery industry, battery etching, where it can be used to charge the battery and then discharge the battery and feeding the battery energy back to the grid from the inverting mode. So for this project, the customer were testing one of our AC to DC power supply, and then in the middle of the test, they find out that when all the motor was on, the unit went into overvolt protection. Okay, and so we find out that it's due to the back EMF of the motor when it's braking. Okay, the power supply went to OVP. So we were looking for a solution. The solution here is we either have to the customer either have to get a regenerator clamp, okay, regeneration clamp circuit to damp down the back EMF, or and then we was discuss about it, and then we were suggesting the BIC 2200, okay, that able to basically shred the back EMF energy from the motor. How it does is because it has the automatic inverting mode that can dump all the energy back to the grid. So on the slide here, we have two photos that oscilloscope photo. So on the left hand side, you see is the DC voltage bus of the AC to DC power supply. The yellow curve is the motor current. So when it's operating, ramping down, you see the red spike on the voltage. That's where the back EMF generated and feed back to the DC power supply and causes to went into overvolt protection. And on the photo on the right hand here is where the customer put the BIC 2200 in the system, and they tested. You see the yellow line is basically straight line, they're not spike. Okay, so when the motor is operating, is basically take all the energy. The BIC 2200 out of inverting mode did the job. It basically shred all the voltage of the back EMF and help the customer solve the problem. They don't have to use another regenerate clamp. It's going to increase cost and also may have EMI issue. So the solution here was the inverting mode of the BIC 2200 did the job.
Gotcha. Okay, yeah. So this one, sounds a little bit more complicated than the rest, but I kind of want to simplify it a bit. So you're saying the BIC 2200, it can help prevent the over voltage protection mode. It can replace the need for a regenerative clamp, those kind of accessories, and also act as a power supply for the machine. So essentially, it's a 3-in-1 product.
Yes, I mean you can think of it like an all-in-one. It is help customer reduce the cost, EMI issue, and so I mean if the customer really if other customer have higher power requirement, the BIC can do in parallel. You can parallel up to 5 units to have 10 kilowatt power. So we just basically we just discover another field or another market for the BIC 2200 beside doing the battery. Doing the battery.
Yeah, that's great. Yeah, so we have one last case. Thank you guys for sticking around for this long. So we have again one more example we'd like to share. So this is our modular power solution. If you guys recall from earlier, the modular products are essentially providing multiple outputs and voltages through one single input. So in this case, we helped one of our customers power a machine designed to remove blood clots. And so they wanted a single power supply that contains multiple outputs in order to distribute that power to different parts of their blood clot remover machine. And while doing so, they wanted to save space as well. So Brian, what's so special about this NMP series?
Yeah. So the application is a blood clot remover, so it's a medical. So it had to have the low leakage current. So the customer need like 5 volt, 12 volt, 24, and 224 volt basically. 5 volt is used to control the controller, and the 12 volt is to power the computer. The other 24 volt is to power the blood clot too. Instead of using 4 power supply, the customer want to use one single power supply. So we suggest the NMP 1K2. So that the total leakage current is low to meet the medical requirement, and also it's simplify the entire assembly for the customer. and also space saving because 1 unit instead of 5 units. And moreover, the NMP is on 1 single unit can also generate less EMI. Okay, the noise of 1 power supply compared to 4 units because there are only 1 switching frequency inside the unit. So the NMP for output help did the job. I mean, it reduce it save a lot of time and cost for the customer.
Yeah, and space as well. And so, for the salespeople who are listening in, the NMP series, it's a great product to pitch to your medical customers. Because not only is it medically approved with 2x MOPP as well as BF rating, but it also helps save space within their product designs. And because essentially what it does is it replaces the need for multiple power supplies, which in turn lowers the EMI noise as well as the leakage current as well.
Yeah, we also have the online website also have a portal where it can help customer to select the model. Okay, they only need to enter the voltage, the current, then it automatically generate the
configuration, right?
Yeah, configuration. They can basically make it easy for customer to configure themselves.
Oh, wow. Okay.
Yeah. It's very convenient. Okay.
Yeah, so you guys can find that on our website. If you need help finding it, please reach out in the comments or the chat below or to one of our engineers and we'll gladly assist you with that. So yeah, with that being said, that does wrap up our Tech Spark for this week. Thank you everyone for listening in. I hope you all were able to learn a thing from me and Brian, but mostly from Brian. If you guys have any technical questions, please feel free to reach out to our engineering team. So on the right side of your screen, you can see Brian, Kareem, and Harlan's contact info for you guys to reference. And also, before you guys go, we do hope to see you all again on April 18th at 11 a.m. Pacific time for our next Tech Spark. This is a special session where our distribution sales manager, Jessica, and product manager, Kai, will be telling you guys a bit more about Meanwhile Power Solutions. Yeah.
Okay.
Yeah, thank you.
Thank you.
My name is Andrew. This is Brian. I hope you guys have a great rest of your day.
Thank you.
Thanks.